Hello everybody, my name is Hello. Welcome back to this series where we're dealing with programming and design patterns in Python. Today we're going to be talking about the facade pattern, which is a very interesting pattern used to hide complexity. So as the term suggests, facade basically hides complexity to make things simpler. Okay, how are you going to do that? Let's say I'm going to be ordering food, for example, right? So what happens if I order food? The waiter will take my order, then the chef will cook that order, then the chef will finish cooking, then probably they'll send it to a delivery boy, uh, and then the delivery boy will deliver it to my home. Or if you're using a waiter, the chef would give it to the waiter will give it to the delivery boy will give it to me, and the order will be completed. Now there's totally 8 or 9 steps in this order, but when you just click one button in Zomato or Swiggy, all of this comes to you. Correct? How does that happen? Well, using facade. That's it. So inside one button there's so much functionality that's triggered, but all of that complexity is hidden to you so that the user does not have to worry himself or herself of all of these complexities. How does that look like? Let's just quickly code this also. It's a very simple pattern. We'll just code the example that we just talked about. So let's say I have some classes, right? So let's say I have a waiter. What will this waiter do? This waiter will first take order, and so this will say something like print your order has been taken. Okay, then we can also do serve self. Okay, and this will do print your order has been served. Okay, that's something that we can do. Similarly, what else did we talk about? We talked about a chef. What the chef will do? The chef will cook, right? So the chef would say print your order is cooking right now. Okay, chef, and then finish. We'll also add that. No, you don't have to add self in any of these. Actually, I'm just creating for fun. But if we are creating instances of this, you would need the self, or else you won't know which you're calling for. In that case alone, that's why I'm adding self. If you don't want to create an object and you directly want to refer to static methods, in that case you don't have to add self. Okay, now you'll say your food is done. Okay, now next we have a delivery boy, right? Delivery boy. What this boy will do, we have, again, let's say start, for example. We can print something like your food has left the restaurant, and then we'll also create a finish function for this delivery boy. We will print this. We'll say your food has been delivered. Okay, now this is all of our class, this is all of our complexity. Let us create a facade to hide all of this. I'm going to just run this code so that I can move on to the next block to make this more readable. I'm going to create a facade. Okay, what does this facade do? Let us say this function is called order food. That's it. Okay, so what will order food do? First, it will create 3 instances, and this is something that you can create either here, or you can create as define init of self. That's something that you can do also, or you can create that inside this class also. Okay, so you can do self dot chef is equal to chef, and similarly you'll do self dot delivery boy. Deli boy is equal to delivery boy, and then we'll have something for the waiter also. Self dot waiter be waiter, right? I can actually change this to delivery. I can change this to delivery. Yeah, this works better. Now, since I'm just doing it here, I'll just refer from here. Now, definitely you can add all of this in the scope of this function also. That's something that you can do. That's up to you completely. Now, what I'm going to do is first, I'm going to take the order. Okay, so what I'll do self dot waiter dot take. The order is taken. Next, what I'm going to do, cook the order. I'm going to do self dot chef dot cook, right? Then I'm going to do finish cooking, right? So I'll do self dot chef dot finish. Okay, then what I'll do, serve order to, or maybe I'll do send order to delivery boy. Okay, in that what we'll do, waiter will serve the order to the delivery boy, out for delivery. Okay, in that case, what will happen? The delivery boy will then start his journey, correct, and deliver to customer. In that case, the delivery boy will finish his work. Okay, so this is the facade that we are creating. How all of this looks like. Now I am not going to be initializing any of these classes from my code. All of this will be done inside facade itself. So when I'm calling this, I will just say order button maybe, or something like that, object, or I'll say application, and this application will be a facade. What I will do is I'll simply say order food. This is the only functionality that the user actually interacts with. But when I run this, what happens? The order has been taken, the order becomes cooking, the order is done cooking, then it's been served to the delivery boy. The delivery boy then leaves the restaurant and delivers to you. So one function triggering so many things from so many classes. How? Using a facade. Why? To hide complexity. I hope this very simple demo on what a facade is enough for you to get an idea of what we're working with here. You guys can try this out yourself. It's very simple code. Thank you so much for watching. If this video helped you provide some light about what this design pattern is, or a bit of better understanding about the facade pattern, hit that like button. If you guys have any questions, let me know down in the comments. I'll be happy to answer them. Thanks for watching. I'll see you in another video. All of this code is in the GitHub, by the way.